Hello friends, Mycrodex here with an update on our work from last time. We made 10 Petri dishes and we are going to check on them today, and you can tell just from looking at them from the side that they got busy. This video will make the most sense if you watch the video just before this one, as this is a continuation of that work. So first we're looking at Phanerochaete sanguinea, and I didn't actually show myself doing the transfers for this, but it's going to be very important for this episode. We'll get back to that in a second. This is a second plate of that same species, and you can tell it's very consistent in how it looks. It looks kind of like spider webs, very, very thin and wispy. Looks nothing like our Panus lecomtei here. These transfers were made on the same day, and you can see that they're maturing at different rates, even though they're being kept in the same conditions. Next up, this is the second offspring of the Panus lecomtei, and you can see it's pretty pillowy. It looks pretty much the same. And this is the third offspring. You can see these two are pretty much the same as well, but you can see there might be a little bit of contamination there from one of the transfers. One of those plates sat around for a while, so there's a good chance that they became contaminated. And I made a good point of that with long-term and short-term storage in our previous episode. Right here we have our maitake. We talked about that in our last episode too. These are all maitake plates. That's the one we took from last time, but we're going to be using that today. And this is the one I've been really waiting for. This is not only the Panus lecomtei, but also all of its offspring. So the first one is the Panus, the one that I touched there. That one is the first offspring. The third one down there is the second offspring, and the last one is the third offspring. Even though they're genetically similar, they are actually genetically different enough to not actually combine with each other, which is why you can see that fine line in between them. I inoculated the sanguinea with the same genetic material in 3 different spots, and you can see the transition between them is really seamless. By combining the entire Panus family together, I can see that they actually are genetically different and that my breeding was actually successful. Speaking of successful, our slants are looking pretty good. They haven't established themselves on the gel in there, but they are not contaminated, so that's just going to take a little more time. So now we're going to move on to taking a plate of each one of those species that we were playing with today, and we're going to be adding them into some sterilized grain. The purpose of this is to pretty much carb load the mycelium so that they can consume hardwood a lot faster, and it'll save us literally months of time. The remainder of the footage in this video is mostly me transferring different samples into the grain in a sterile manner. I'm using a metal blade, and I sterilize the blade with a torch just to make sure there aren't any extra microbes on the tip of the blade when I'm putting the single species into the sterilized grain. And then I will let them sit around for 1 to 2 weeks so that they can eat that. It is getting a little colder though, so it might take a little longer than 2 weeks. We'll see. The warmer it is, the better. Up to a certain point, you kind of want them to stay at the same temperature while they're colonizing and doing everything that they need to do. And then we can move them on to wood later, and we're going to show that process when we get there. Here we're just moving the maitake over into some grain and then wrapping it back up. And then always when you do this work, you want to make sure that you label everything. So I'm going to line everything up. I put the plates corresponding with each grain spawn on top of them, and then I shook the jar up so that the sample would fall down to the bottom. Otherwise it might dry out on the top, and I want to give them direct access to those grains. Okay, so that's plenty of info for this episode. I do want to leave you guys with a better look at just how territorial the mycelium is, even though they are coming from the same family tree. Once they claim those resources, they're really not trying to let it go, and they're going to try to grab up as much as they can. Hope you guys enjoyed the video. If you did, or if you learned something new today, please drop a like and subscribe. I'll be dropping a video every Friday, and if you want to see some behind the scenes action, please check out Mycrodex on Instagram or go to the Mycrodex website.